We all start exactly the same way. Two microscopic cells merge, divide, and multiply into a cluster that eventually becomes a complete, functioning human being. Over the course of 9 months, that cluster executes one of the most complex biological construction projects on Earth. The first 2 weeks are known as the germinal stage. It begins the moment a sperm fertilizes an egg to create a zygote, a single combined cell containing a complete set of human DNA. This zygote immediately begins dividing as it travels down the fallopian tube. After about 4 or 5 days, this cluster of dividing cells forms a hollow ball called a blastocyst. To survive, the blastocyst has to reach the uterus and embed itself deep into the uterine wall, tapping into the mother's body to secure a steady supply of nutrients. This timeline graphic tracks the first 8 weeks of development, highlighting the critical split that happens around week 3. The outer layer of cells branches off to form the placenta, while the inner cell mass becomes the embryo itself. By week 5, the neural tube, which becomes the brain and spinal cord, takes shape, and a primitive heart actually begins to beat. Because the body is rapidly constructing its most basic organs, the embryo is incredibly vulnerable right now. Any exposure to external toxins, like certain drugs or alcohol, can severely disrupt this fragile cellular assembly line and trigger permanent congenital disabilities. These first 8 weeks dictate the entire structural foundation of the human body. Early, targeted maternal intervention is an absolute necessity for the embryo survival. You often hear the phrase that pregnant women are eating for 2. In reality, early maternal nutrition acts as the primary chemical defense mechanism protecting the developing embryo from structural failure. The mother's diet must contain high levels of folic acid. Folic acid is actually a synthetic form of vitamin B9, and the embryo relies on it to successfully close the neural tube. A lack of this specific chemical building block puts the baby at severe risk for catastrophic spinal cord and brain defects. At the same time, the mother's own physiology is under immense strain. Consuming targeted doses of iron and vitamin B6 helps support her rapidly expanding blood volume while directly combating the severe nausea and vomiting common in the first trimester. First trimester nutrition prioritizes exact chemical components over simple caloric volume. The mother's body requires these specific materials to construct a central nervous system from scratch. By week 9, the embryo graduates to the fetal stage. The heavy lifting of organ formation is mostly done. The biological objective shifts entirely toward the rapid growth and maturation of those existing structures. The fetus hits several major physical milestones over the next few months. Cartilage begins to ossify, hardening into real bone. A thick, waxy coating called the vernix caseosa forms to protect the skin from the amniotic fluid, and the diaphragm starts making rhythmic movements, practicing how to pull air into the lungs. To fuel this massive spike in fetal bone and muscle growth during the 2nd and 3rd trimesters, the mother's body demands a heavy influx of calcium and protein. If she doesn't get enough from her diet, her body will leach calcium from her own bones to supply the fetus. This rapid mass accumulation takes a physical toll. The expanding uterus compresses the mother's internal organs, leading to elevated blood pressure and severe constipation. She must adjust her diet, relying on high fiber intake and intense hydration to maintain her body's normal baseline functions. The final 2 trimesters are a biological marathon. They relentlessly test the absolute limits of the mother's physical reserves, draining her energy right up until the very moment of birth. The culmination of this 9-month process is delivery. Deciding exactly how that baby enters the world requires a highly calculated medical assessment. This comparative matrix breaks down the mechanics of a normal or vaginal delivery. It features a fast maternal recovery time of 24 to 48 hours, alongside a hidden biological benefit. The physical pressure of passing through the birth canal actively compresses the baby's chest, squeezing excess amniotic fluid out of their lungs before they take their first breath. However, that same intense pressure can severely stretch and damage the mother's pelvic muscles and tissues. In many cases, this structural trauma leads to long-term issues like urinary incontinence, where the mother temporarily loses control of her bladder. On the other side of the matrix is the cesarean section. This surgical delivery is an absolute necessity for high-risk pregnancies or fetal distress. Yet it comes with the realities of major abdominal surgery, significant blood loss, potential infection, and a painful recovery period lasting weeks instead of days. Neither method is universally superior. The medical team makes a strict risk-reward calculation, balancing the mother's structural safety against the immediate survival needs of the baby. The exact moment of birth is what medical professionals call minute zero. Instantly, the baby is cut off from the umbilical cord's oxygen supply and has to successfully transition to breathing atmospheric air. To assist this transition, doctors intervene immediately. They use a simple suction bulb to manually clear mucus and fluid from the newborn's nose and throat. Once the airway is clear and the baby is breathing, the umbilical cord is permanently clamped and cut. This scorecard breaks down the APGAR test, a universal rapid assessment tool administered at exactly 1 minute and 5 minutes post-birth. It measures 5 vital categories: appearance or skin color, pulse, grimace or reflex response, activity, measuring muscle tone, and respiration. Each category gets a score of 0, 1, or 2. If the infant's cumulative score falls between a 7 and a 10, their heart and lungs are functioning properly, and they are successfully adapting to the outside world. Those first 5 minutes represent the single most dangerous biological transition a human will ever make. Without this immediate codified medical assessment, doctors wouldn't know if the infant was secretly in distress. Even with a high APGAR score, the newborn undergoes a rigorous head-to-toe physical exam within their first 24 hours. Doctors scan the skin for common harmless conditions like erythema toxicum, a rash consisting of red blotches with small white bumps. They also check the infant's head shape. During vaginal delivery, the newborn's skull bones actually overlap to survive the birth canal's intense compression. This temporary shift often gives the head a distinctly cone-like shape for the first few days. Next comes the neurological assessment, where doctors test innate survival reflexes. They check the Moro reflex, where a startled baby instinctively throws its arms out, as well as the rooting reflex and the sucking reflexes that ensure the infant knows how to feed. Finally, before the infant leaves the hospital, they receive vital prophylactic treatments. This includes their first hepatitis B vaccine and a crucial shot of vitamin K to prevent severe internal bleeding, since babies are born with naturally low levels of the vitamin. Creating a healthy human requires 9 months of incredibly complex cellular biology. Securing that life permanently requires highly targeted maternal nutrition, calculated delivery methods, and rigorous medical intervention in the critical hours after birth.